a function is a form of relationship between two types of data points. So this particular, whatever a function is when we don't have repeated x values. Okay, so in a table of values, when you're given x and y points, a function will have 6, 8, 10, and then we'll go 4, 5, 6, 7, 8. Okay, so a function will not have the same x value for multiple y values. So yes, this one here is a function. This table here would not be a function. So if I've got 2, 2, 5, 7, 9, and this one was 4, 5, 6, 7, 8. Okay, this one's not a function because my 2's appear twice.
Can't they appear twice in the y?
They can appear twice in the y, yes. So if you have the same number twice in the y, that is still a function. Now let me show you why that is the case. Ha ha ha. I'm so funny. Oh, I know I am. Thank you, Chelsea. Okay. So if I'm given a graph that looks like this, okay, this is a very standard graph. It's a parabola, and we'll see this when we talk about quadratics next year. But when you look at this y value appears over here and over here. It's the same y value on both sides. So you can have two y values. But there's only one x value for each, or the x value only appears once. So there's no duplicates of this. What we can do is this thing called the vertical line test. So if you draw a vertical line at any point on your graph, it only touches one part of your graphed line. Okay, so this line only touches here, this line only touches here, this line only touches here, and this line only touches here. So this graph is a function. Okay, whereas if I draw a graph like this, okay, this graph, if I drew lines vertically down through them, this line touches the point of our line, this line that I've drawn touches our graphed line twice. So if it touches it more than once, that means we have a repeated x value, and it is not a function. Okay, the last thing we can look at is the equation. The equation of a line, if our x is to the power of 1, it is a function, and if it is anything else, it is not a function. So, 1 or 2. So x squared is a function. X is a function. Anything else is not. Pardon? Do you feel hot air coming at you? I can't control it. Sorry. Okay, so you can also have a line that looks like this. Okay? This line is not a function. However, a line like this is a function. So the slight difference that I had drawn before is that I had vertical line. That was bad, but you got the idea. There was a straight line down. That turned into a circle. Okay, I give up. You get the idea that I'm trying to say. If the x value appears once or it does not pass the vertical line test, it is not a function. If you are given an equation of a line, okay, so our equation of a line, let's just remember what that is here. Is y equals mx plus b, where b is our y-intercept. M is our slope. And x and y is a point on the graph. I'm just going to underline the x and y's there. Okay, so the equation of a line we use regularly. We use it if we are given random pieces of information. We can get it from a graph. We can use it to make a graph. And whenever we're trying to figure out what to do with this, we want to go back to either our graph or a table of values. And so we can go, if we're given y equals 1/2 x plus b, my little tip for you, because you can pick your x points that you're going to plug into this table of values. If I'm given a fraction for my m, I like to go up by the denominator. So in this case, every x value I choose is going to go up by 2. So I'm going to go 2, 4, 6, 8. If I was using the equation y equals 1/3 x plus b, my table of values, I would suggest going 0, 3, 6, 9. That's because when you multiply that to the fraction, you're going to get a whole number there. And it's just a little bit easier to work with. So let's just say this is 1/2 x plus 2. When I go to solve it, I'm going to plug in my x value into this spot here. So I'm going to say y equals 1/2 times 2 plus 2. So 1/2 times 2 is just 1, plus 2 is 3. So y equals 3. And I'm going to solve for each of those points, okay? Once I've solved for this point here, I can put it onto a graph. So I'm going to erase this one here. So I can start to graph this out. So my x was 2. So 1, 2. And my y is 3. So 1, 2, 3. Which means that my point on the graph is right here. And that's my first point. Now, you should be labeling your graphs, okay, with axes. So I should see 1, 2, 3, 4, 5, 6, 7 written out here. And then the positive values as well, just so I know what you are increasing each box by. Okay, if you choose to go up by 2s, that's fine. If you're going up by 10s, that's fine. It doesn't matter, but you do need to label it so that I know you've done it properly. Make sense? Okay. If you're given a graph, so I'm just going to keep, I'm going to draw these in here so we can use this as an example. If I'm given a graph and I want to get a line, that was a bad dot placement at the end here. Okay, so this is the line I'm given, and I want to go from line to equation. I'm first going to look on my graph to see if I can count what my slope is. And so I can look at that, and I'm going to pick 2 points on this graph. So I'm going to pick this one right here and this one right here. And what I'm going to do is look at my rise over my run. So my rise over my run is my change in height versus my change in my left to right. So my change in height is 1, 2 spaces. And my change in my run is just 1. Okay, so the slope for this one, so what I would plug in for m is just 2 over 1, which I could just write as 2. Now, let's say you couldn't count your slope because maybe your numbers are a little bit off, or, Kevin, what are you possibly rapidly typing out there? What are you possibly typing out so fast on that computer of yours? Okay. So let's say you can't count them for whatever reason. Maybe the numbers are really off. You're using decimals. It's just a little bit too complicated, or you don't know, what exactly the placement is. We can use our y2 minus y1 over x2 minus x1. So again, it doesn't matter which point it is. So maybe this one here I'm going to list as x1 comma y1, and this one here will be x2 comma y2. And I'm going to plug that information into my formula here. And so my x2 was my 0.2. Whoops. So 2 goes here because this is 1, 2, and that's my value for x2 here. Okay, if I draw it right down to where I've labeled it. And my y2 for this one here is 3. My x1 is just 1, and my y1 is just 1, and then I can simplify that to 2 over 1. So you get the same answer either way. It's up to you which one is easier. It will depend on which type of graph you are looking at. Or if you are just given points, 2 points, you're going to want to use this method that we just went over on the left side of the TV here. Questions? Okay, last thing I want to review with you guys today is sometimes you're given an equation that's a little bit out of order and you have to rearrange it. So you might be given something like 4y plus 2x equals 15. Actually, I'm going to make that 16. Okay. What you need to do is rearrange this so we get it into the form y equals mx plus b. So I'm going to start by moving my 2x to the other side. So I'm going to have 4y equals negative 2x plus 16. Because I've moved my 2x over. Now I can see that I've got my 2x, which is like my mx here. So negative 2x is like my mx. And I have my constant, which is my b. I need to get rid of the coefficient or the number in front of our y. So I'm going to divide both sides by 4. So then I'm left with y equals negative 2 over 4x plus 16 divided by 4 is 4. Now I can look at this and I go, okay, I've got it in the right form, but I do need to simplify that one fraction. So I'm just going to simplify my negative 2 over 4 to negative 1/2 x plus 4. And now I have my equation of a line, and I can answer what my slope is, what my y-intercept is, and I can find any point on the graph. Okay? Questions?